Types of probability distribution in data science. Hi, I'm M. Asif Hussain from KnowHow Academy. What are we going to learn in this video? We are going to see what are the different types of probability distributions we have in data science, examples of each probability distribution. So at the end of this video, you are going to learn and understand all these different types of probability distributions we have in data science. So let's walk into it. When I'm talking about the word probability distribution, it might be looking something unique or different or a bit tricky to you. But if you just split the two words, probability and distribution, so we have explained in our recent videos of our data science what exactly is probability, the formulas of probability with various case scenarios. Now let me talk to you exactly what is meant by distribution. In the name itself we have distribution, the possible values a variable can take. What is meant by distribution? The possible values, it might be a number of values, the possible values a variable can take and how frequently they occur. That's a distribution. Alright, so now if I talk to you about the different types of distribution, so let's learn this with a simple example. So here, let me consider that I have a die. We all know what is a die, right? And I have a card. So the distribution here, it shares some features where we group them together. Okay. If we group these together, and if I would like to talk about, they have the finite number of outcomes. Okay. So when they have the finite number of outcomes, we call this as a discrete distribution. A discrete distribution, it have such a kind of features where they group the different possibilities and they have the finite outcomes. That's where discrete distribution comes into the picture. Alright, so this is the first type of distribution that we have. So now let's learn the another type of distribution. So for that, let me give you a simple example. Okay. So we have a car, all right. So in this car, when we are trying to drive the car, until or unless there is some force given to the car, it cannot move. Am I right? So a car is in a rest position. So when we apply some force, then the car starts moving. Am I right? So let us consider there is some speed of a car. We generally calculate the speed of a car, a vehicle. So how is this speed happening? This speed is happening when some force is applied. Am I right? So if we try to record the speed and the force of the car, force might vary, speed might vary. Speed from 10 kilometers to 20 kilometers per hour, 20 kilometers per hour to 60 kilometers per hour, 60 kilometers per hour to 100 kilometers per hour. The speed might vary. How is this speed varying? With the number of forces that we are applying, right? We apply as much as force we apply, as much as speed the car moves. Am I right? So the point here is that there are infinite outcomes of this speed and force. I'm right, they have infinite outcomes. There is not one outcome. Okay, so this car will go in this speed, that's it. No, there are infinite number of outcomes for this car, right? So for this speed and force, so when there are the infinite number of outcomes, then we call this distribution as continuous distribution. So this type of distribution is called as continuous distribution, which is having a infinite outcomes. Alright, so now let's see the another type of distribution. So here for this, let me take two events A and B. Now for this A and B, let me give a small example. There are two seats, okay, in a movie theater. There are two seats, seat number 1, seat number 2. In seat number 1, A can sit here, B in seat number 2, B can sit here, or B can sit in seat number 1 or A can sit in seat number 2. So the reason for telling you this example is that for this there are only two possible outcomes. So the events, when we are happening some events, the events with only two possible outcomes, we call this as the Bernoulli distribution. Now any event with two outcomes can be transformed into the same but the Bernoulli event. So for this, let me give you a small example. So we have a team in a company. Am I right? Working in a project. Okay. So in this particular organization, as it is a MNC company, let us consider, okay, there are 7 national employees and this company is in India if we consider, and there is a project, and for that project we have a team, and there are 3 international employees. Okay. So now the team leader, okay, we call it as a TL. Am I right? It's a general terminology we use in IT sector. Okay. So this team leader, he has to or she has to, if it is considered 2 possibilities. Okay. So if he has to be with the 7 national employees, if we consider this as a true, and with the 3 international employees, if we consider this as a false, so there are only 2 possibilities. Either it can be true or false, or it can be false or true. Okay. If we do similar experiments n number of times, right, so we get only 2. That's where Bernoulli's will come into the picture. But the same thing, if we do the similar experiment n number of times in a row, then we come up with the distribution called binomial distribution. Okay. Only 2 possible outcomes is Bernoulli distribution, but if we repeat it n number of times, when we have many iterations, then we go with the binomial distribution. So the condition for the binomial distribution is it will be having many iterations, which is number 1. And number 2, the very interesting thing is that for every iteration, there will be only 2 outcomes. So if we consider binomial distribution and Bernoulli distribution, these both are interlinked with each other. Alright. So the conditions for the binomial distribution is that we can go with several iterations, n number of iterations, but for every iteration there will be only 2 outcomes. So that is the binomial distribution. Alright. So now let's walk into the another type of distribution that we have, which is Poisson distribution. Okay. I'm not talking about the Poisson that we generally know, but this is a Poisson distribution. Okay. This is in a math. What exactly is this Poisson distribution telling it at? We use this particular Poisson distribution to test how unusual an event frequently occurs in a given interval. Okay. When we use this Poisson distribution, we use it to test how unusual an event frequently occurs in a given iteration. So for this, let me give you a simple example. Let us consider that we have a person who is very good in playing basketball. Alright. So now we have only one person. So he has to get 35 points per game. How many? He has to get 35 points per game. Now there might be n number of games. 1 game, 2 games, 3 games, 4 games or what. But per game, 35 points he or she has to get it. Now the point is that the condition here is that 12 points in the first quarter of his next game whenever he is or she is playing. So for this, what is the probability here? The condition of probability is probability of 12. Using this Poisson distribution, we are able to determine the chance of getting or the chance of scoring exactly 12 points for a specified interval. So this is nothing but a Poisson distribution. So now let's understand the another type of distribution that we have, okay, which is normal distribution. In the name itself we have normal distribution, which occurs everything in nature. So the outcomes of many elements, they resemble in this distribution. So that's why it is called as a normal distribution. So now for this, if I give you a simple example, let us consider how many of you know the bear? Okay, we generally know the bear of a forest which is in a black color and all. But how many of you have really seen a polar bear? Okay, which will be in a snow, probably completely in a white color. So the weight of a adult male polar bear, if we consider, is 500 kgs. So whenever I'm talking about this normal distribution, or it comes under the category of this continuous distribution, here let us consider with a small graph. The graph is that the distribution starts from this point, but it will not start from here. It will not start from the center point, 0. It will not start from here. It's starting a little bit above. So if we consider here as a minimum age as 350 and the maximum age as 700, but the distribution that we have or the weight of the adult polar bear that we know is some 500 kgs. So this is the outline for us. Okay, so this is a normal distribution. Now let's look into the another type of distribution called as the chi-square distribution. Okay, what is this chi-square distribution? Okay, this distribution is the first asymmetric chi-square distribution where it allows the non-negative values to have it in a calculation, in a non-negative value. So here one thing that we have to see, that this type of chi-square distribution, we generally use it in a hypothesis testing. How many of we have remembered hypothesis testing that we learned in our 10th standard? Okay, if you see the graph of this, the hypothesis testing, this goes like this, right? So it is used in hypothesis testing to determine the goodness of it. Okay, so we generally use this chi-square distribution in the hypothesis testing. So when we are working with the statistical model in a data science project, when we are facing some kind of statistical problems, okay, where we are stuck with the analysis part, then we use this hypothesis testing or chi-square distribution to solve some parabolic kind of problem statements. All right, so the another type of distribution that we have is exponential distribution. So events that are rapidly changing, or I can call it as a frequently changing. So for this, let me give an example. The example of social media. We can see the social media feeds, we can see the social media updates or the news in the social media that will be frequently changing. Okay, there is no constant time for it to be, we get a frequent updates every second. You refresh the page, new updates, you refresh the page, new updates, you refresh the page, new updates, right? So it is rapidly changing. That's where we can relate this exponential distribution with this kind of real-time example. But if you talk with the data part in the technicality of data science, if the data is connected live, for example, you take the population of the world, so the every millisecond the population of the world is frequently changing. Okay, it is rapidly changing. There is no okay, so this is the number, XYZ is the number, okay, it stopped. No, it's changing. Every millisecond it's changing. Am I right? So that's where we come into the exponential distribution. The last type of distribution that I would like to tell to you is logistic distribution. Okay, so the another type of distribution is logistic distribution. When do we use this logistic distribution? We use this in a forecast analysis. It is used to determine the list of successful outcomes. So what is meant by forecast analysis? We know what is meant by forecast analysis, right? So let us consider the geographical data, let us consider the weather report and so on. We consider the forecast analysis for this. Even in the projects that we are working, if such as data we have where we have the region information, weather information, longitude, latitude data. So for that kind of data, if you want to have some analysis part, then we go and use this logistic distribution in the projects. So these are the different types of distributions we have in data science. So thank you for choosing KnowHow Academy as your source for IT knowledge. We are always here to help you to navigate the tech world. If you have any questions, do not hesitate to reach out. It's been a pleasure sharing this information with you. Stay curious and keep learning.